Okay, good morning. We are live. Hi. Where have I been the last couple of days? Well, we've been doing some really stupid work. And let's put it this way, right? I got PufferLib down to, 4,000 lines. And I looked at the code and I went, if I spent the next couple weeks working on cleaning this up, I could probably only cut another 300 lines off of this. And I wasn't happy with the way it looked. There was a whole bunch of bloat coming from Torch, a whole bunch of fancy things that you really couldn't touch too much that could just break. I wasn't happy with it. And then I thought, Torch really isn't doing that much for us here. It's quite a bit of refactoring work in order to get this into something without Torch, just the way it's set up. But it's really stupid work. I can probably do a lot of this with Claude as long as I'm actually checking shit and writing tests and all that. It's just going to take me an extra 10, 15 hours of work this week. So I figured I'd put in the work. And I've worked till 10 or 11 the last couple of evenings, put in quite a few extra hours. And let me show you the result of this. First of all, boom, fast build. Caches, but also 5 seconds or so fresh. All right, so look at this. 1, 2, 3, 4, 5. All right, a little longer. 6. Yeah, 6 seconds, whatever. So you'll see here, there's no torch anywhere in here, right? No torch. And we are able to train this thing in like 6, 7 seconds. This is on my local machine with the stream running and everything. And look at the score, 859.978. Remember this number. I'm going to run it again. Exact same number. That's right. We have fully deterministic training, fully reproducible, all in static memory, no dynamic memory allocations during training, no torch. Boom. Pretty good, right? Pretty good. And if we look at the latest word count, you can take off about 900 lines. Was it 800 some odd lines? Yeah, for PufferNet. So about 5,000 lines of code is what we have for everything. If we can get this number to 4,000, I will be much happier. I think that is the major goal. I really want to start cleaning this up manually. I think, unfortunately, there's still going to have to be some more Claude bullshitting. But we're going to start the stream today just by spending a little bit of time looking over the code and kind of getting a picture of stuff. First of all, this file is about the same length as it was before. We can get rid of these, actually. Get rid of this. We have puff slice. Yeah, so we're probably going to want to set up some basic, a little bit better of a tensor. Hey there, you said no torch? No torch. This is raw CUDA. Isn't that cool? It just got to the point where we ship a Theseus it. Like, Torch was doing so little for us anyways, it was, like, causing more problems than it was worth. We have an extra 1,000 lines of code at the moment for a bunch of bullshitty little custom kernels, but I think we're going to ultimately get the code around the same size it was before with no torch. And faster, and static memory, and fully reproducible, and a bunch of other nice things. And honestly, I think this is going to be easier to think about, because now all you have to do is you think about CUDA. So all the stuff that Torch brings in, all the bullshit of Torch, you don't have to think about at all. And it will still be Torch compatible. Like, if you want, you can just take any of our stuff from here. You can just call, like, from blob on the memory, and you can just run Torch ops. I almost don't even want to call call this a tensor, because it's just memory. Hi, user. Fully reproducible action distribution. Yup, everything is fully reproducible. I'm still banned on YouTube. Really? I remember unbanning you on YouTube because that was a misclick. Let me go check. I was almost positive I had, like, gone in and unbanned you on that. Five. Let me figure out where your thing is so I can unban. That was just, I swear that was a misclick, man. Okay, settings. Playback. Unban you. Settings, community, hidden users. Hi, I'm trying to get, oh. Wait, here, this one just didn't show up. Oh, no, there it is. I'm trying to get into reinforcement learning as a hobby. I'm a software developer with a few years experience. How would you recommend getting into it? You are the ideal target audience for the exact content I have already written. So it will actually be very easy for you. Let me show you. Why do I have 20 plus notifications? What in the heck? Oh, this got some cool attention. That's nice. That's very nice. This article. If you're brand new to programming or to ML, you can start here, but otherwise, follow this article. This exact thing. It'll walk you through step by step, building a couple of ends. And this will be enough to already be contributing productively to the science. All right, where is settings? Where the heck is this? And why does YouTube make it so freaking complicated to find anything? It's not here. Distributed computing, yeah, it'll work, Debris. It's just NCCL. I actually don't know with the new version if there's additional setup, but it's literally one all reduce op. It's really simple. Unban. Hang on. Now I have to go watch a video in order to figure out. Oh my god, how do you make it? What the hell? I swear, what is wrong with Google engineers sometimes? Oh, here it is. Community moderation. Okay, which one of these is you? Is it Lance? It's Lance, right? Okay, there you go. Happy? Should be unbanned. No problem. If you want to figure out and test the all reduced stuff once I have this cleaned up, you're more than welcome to. We definitely need to have that working, but look how simple it is. All right, this is it. There you go. That's null reduce. Not hard. We actually had that working with Torch even before I ported it because it was too annoying to figure out how to use Torches distributed. It was literally easier to just do an all reduce. All right, let's see. So, what in the hell is this? Yeah, no, this is terrible. That's multi-GPU, not multi-GPU machines. I don't know. Can you not just do that over multiple machines? I think there's some setup associated with it. Made an env. Should I create an PR? Depends what the env is. If it is like the 2-pixel Flappy Bird or whatever, no. If it's like a full, if it's something at least the complexity of like a full game of Flappy Bird, then sure. Try to hack something together. Cool. X-Link. Oh. Yeah, let me do that. All right, we'll do that real quick and then we'll get focusing, all right? I have to update the one on the website too, is the annoying thing. And publish this. Okay, that one's done. Wrong freaking. Like squared. If it has any use, then yeah. I mean, go PR it and I'll look at it at the least. I don't bite you for PRing stuff as long as it's not AI slop. Is it linked on here as well? I don't think I have it on Twitch. Oh yeah, I do. J Suarez. Cool. Saved on both of those. So at least those two are updated. Warburg has been running nicely on Puffer. Plus 5 billion steps, 1.2 mil. And VOBs are huge. Our new vectorization should help a little bit. It buffers the transfers. Pleasure to work with. Good. I'm trying to make 4.0 way nicer. It's just so much work, man. Dropout and norm that was missing. Why do you need dropout? Dropout's for regularization. You have unlimited data. Norm sometimes helps, sometimes does not. We don't have norm layers because norm layers are incredibly inefficient. They're very slow. It's actually very difficult to implement a good norm kernel. You look at an RMS norm and it looks very simple. Yeah, you get an absolutely horrible cross terms in the backward pass for an RMS norm. Yeah, so we're absolutely not going to have anything that looks like this in the Puffer code base. What the heck even is this? Hmm. Own data center server that we don't want to overfit. I see. Is this thing? Oh, this is the finance one, right? Yeah, I remember you now, Lance. Okay. And every time I hear Lance, this is what I think of. Here. This is you, right? You're this dude? Think of the Pokemon Emerald Gym leader. Awesome name. Is that actually your first name's Lance? Because if so, that's an awesome friggin' name. Yeah, I get to be Joseph. Biblical. Lancelot? Are you kidding me? Oh, that's awesome. That is friggin' awesome. I mean, with a name like that, you have like an obligation to be, like Jack's Tech Paladin, right? Hey, Jess. Right-hand man to the Pharaoh. That's fair. That's Farah, you could say. Other than yeah, that's also fair. See ya, man. Yo, Jess, we got no torch training. It's about 5,000 lines at the moment. We're gonna try to get it down to 4,000. No torch required. Static memory, fully reproducible, fully deterministic training. It's pretty good. Jeez, what on earth is this? Still using their tensors? Nope. Literally nothing, Jess. It doesn't even compile with Torch. Like, we're not even using Torch in compilation. So it compiles like 5x faster. Yeah, it's pretty cool. Yeah, here's a model we trained. Look at that. Where is it? Videos. This one? Nope, that's something else. Nope, that's something else. Heck to go. That's weird. Whatever. Did we give it a torch? Yes, we did. It's gonna still be torch compatible. We're kind of going through some stuff at the moment and looking for fluff. Yeah, so it's just like stupid flawed. To get this into like just iteratively we refactor this until it's less stupid. Actually, I can just say like we'll get like the first couple little ops done first. Clamp. Yeah, so this is one of the things I'm not sure about is like we have a couple weird kernels like this transpose 01 and stuff. But this actually looks very, very similar to the code before, doesn't it? Kind of just goes to show you Torch wasn't really doing anything. This is a little bit of a mess. Edit this. I mean, I only really see the problems in the body of... Well, maybe we'll actually be able to see once it applies refactors. When you replay the runs, how do you chain multiple runs together? Is that a built-in feature? When you replay, it just resets when it finishes an episode. Yeah, that's just normal. Here's a restroom real quick. Yeah, give me a few minutes, folks. I'll be back. And then we will start refactoring for real. Okay. When did you get rid of Torch? Hey, Jess. Yeah. When did you replay? When you replay the runs? Okay, no, I answered that. Cool. Let's figure out where all this crap is coming from, right? I think we just have this massive create function. Yeah, look at this init function. This is huge. The heck? How long do you plan on streaming today? Long time. We stream long time. This shit doesn't get used, does it? Oh, I have to not modify the file while it's doing that. Okay. I see. Let it do this first so I can actually read the freaking code. PufferL.py. I don't think they are used in PufferL.py. I think it just made that shit up. Do you mind explaining what you did different from Torch in your implementation? Well, we weren't really using Torch for that much to begin with, Jess. Like, we basically ship-a-theseused it to the point that we had 5 custom kernels, and the autograd was just calling dot backward like 5 times. So what's the point? The design of Torch also sucks. Like, by default, you're allocating memory all over the damn place. I was not able to get Torch to actually be deterministic, even though it's Kublas is supposed to be. It was pretty stupid, honestly. Yeah, let's just have it one line everything. Yeah, you don't save line count by doing this shit. We also have some nice other things, Jess, like we have stuff in contiguous memory, so a lot of our ops are way simpler. But like the goal is not to just make Torch but better. Like I wouldn't go try to make Torch but better unless it really sucked at what it did. Like Torch has some problems, but most of the problems are not the execution of the design, it's the design itself. Like okay, sure, some of their code's a mess. Actually, a lot of their code's a mess, but it's mostly like just too many tiny little ops getting chained together, not in the same kernel. Okay, now everything is not one-lined. And it should be the last one. Cool, so let's not do too much of this. Oops. Interesting. Should be the same result. Yep. And I'm pretty sure these just do not get used, so I see. I think we can just delete all this profile jank. Train rank. I see. Hmm. It's better. So essentially a lot of today, the reason I didn't stream the last couple days is because it was really, really stupid Claude slop crap. Now it's like much more directed, so at least it's going to be me looking through and actively trying to find stuff that we can improve with the code and looking for redundancy and stuff. The last couple days, the problem was that we just had such a huge amount to refactor, and each individual op was pretty stupid, but like there's essentially nothing to even do with it. And it was a very strongly verifiable process as well. Like stuff like this is just, okay, we no longer need the profiler here. We can move the profiler in, and boom, look, the Python gets a little simpler. Yeah, we'll put this window here and this window here. Nice. So go our stats. 67. Good. Very good. This function is ridiculous, right? Like you shouldn't have to do this. In the meantime, we had a whole mess of notifications. So apparently somebody had a cool env. What? Oh, cool. Just me, the gym, and ML. His ramble ramp, but he's 19, so cool. Glad it helped. Ooh. Hello. What's this? What's this? Wait, what is this? Oh, it's Survivors. Cool. I train with browser-based front-end environments. Yeah, this doesn't work, you scammers. Do not say, oh, we can just do the thing that the puffer does if you do not know the perf requirements, my guy. Alright. I mean, this is just so that we know memory usage, right? Anybody else I've missed? Gotta love seeing people building nice ends. That's it. What's this project in? Rayson just rocks. Honestly, if I were gonna pick like one programmer to go read a bunch of his code to try to learn more myself, it'd be Rayson. Okay. Okay, GPU memory after close leak is 121 megs. 158. But I don't think this is a real leak. 124.1. I've got a better idea. Oh, is it not consistent? That's super annoying. Okay. Yeah, we'll just do that, and then we'll just do a couple trains like this. I'd really like it if there would be a way to not have this be a thing. Oh wait, we have to do setup.py, we need to build this. Wonder if it's worth making this not even need the Python wrapper at all. The only thing is our dashboard. I guess our sweeps in for our dashboard still gonna need torch. It's pretty nice to see these 7-second full solve experiments on my low-end machine. That's pretty cool. Okay, so +0. Okay, it's +0, cool. What do you consider low end? I have a 5070 in this machine. This was a pre-built for 2K. So, how much is an Apple laptop these days? I know I'm gonna get the stupid ads now for this, but you can't even buy a Pro for that anymore, can you? Oh, you can. You can buy a... Where is it? $14-inch. You can buy an M4 Pro for 2K. So same price as one of these slow ass things. There you go. M1 is going around 700. Isn't that like super old now though, dude? Okay, maybe this is not a low-end machine. This is a mid-end machine, realistically. Yes, this is not a low-end machine. But come on, 2K? 5070. You can rent a 5070 for what, 10 cents an hour on Vast? I don't know why their prices are so screwy. We're 5070 on here. 5070 Ti is 9 cents an hour. 5070 is 8 cents an hour. I think we've made it like plenty accessible. You were able to get a 5080 machine for cheaper? New? Good deal if you did. I just get mine from main gear because I have the fewest problems with them. I just buy all mine from main gear. New? Solid deal then. And I bought this thing in like 5 minutes, man, because I realized I needed a desktop in Florida and I needed something to be here. I figured, yeah, it won't be so high end that I can like waste time gaming on it, and then I realized, oh wait, the game I spend the most time on is frickin' RuneScape. I can play that on a potato. Okay, this is why we write the test instead of telling it to just do stuff. Because that would have been a 16 meg leak. That would have been really, really bad because you would not have seen this until like, what? 160. Yeah, you wouldn't have seen this till several hundred experiments into a sweep. What? Well, now the leak is gone. What the heck? Wait. Excuse me. How the hell does this make any sense? One. So no leak. How's the progress been, FBR? We have super fast training, static memory, fully reproducible, deterministic, same result every time with no torch. So I'd say it's going pretty well. I just have a bunch of crap to clean up though. Minecraft clone would be... I don't know what a... I don't want to do that project, man, because that would be a substantial project, and like... If I do anything, if I do any like custom game ends at the moment that aren't client work or aren't like, investigating a new branch of science, it would probably be porting RuneScape stuff. Yeah, this shutdown function is still massive. Oh, but it's mostly... Do this. Oh, this is not bad at all now, right? It's not bad at all. Of any amps that you haven't made, just like it's a big thing from here. And honestly, it's probably really shitty because the easiest way to do it is very AI heavy. Um, I don't think it's like AI heavy doable by somebody who literally doesn't program, but it is like AI doable by an experienced programmer using approximately two brain cells, um, which is just like porting. There's Coliseum, but then there are also like their existing private servers for RuneScape. Like I would think that porting that engine and then specific scenarios, which is one of the things I started doing on stream. In fact, even the Inferno would be like finishing that project would be a good start. Because the only thing I can basically think of that's left is having a really, really big environment. There are some test environments that we still need. For instance, like Tim's Sokoban environment is going to be incredibly helpful. And there probably are a few others that I'm not going to know until I see them. There are also some open NPRs that could use review that I need to go review, and I haven't had time to do yet that will be useful. But I think for big environments, it's like assume we're going to solve Neural MMO 3 sometime reasonably soon, this year at the least, and then like Neural MMO 4 will have to happen. I also don't know, like, if I just go port the entire thing, if I'm gonna run into like legal trouble with that. I don't think so. I'm gonna have to go figure that out. Harlequin and the foundation models. You could, Jess. I think it would be quite difficult. It's not the reason I'm excited about RL though. You don't need foundation models for RL to be useful when you can just train them super fast. Is it still worth learning C and C++? What do you mean is it still worth learning C and C++? Like, abso-frickin-lutely for C. C++ is a complete disaster. I hate it. You'll see that I'm very quickly deleting most of the C++y things in here and getting them to look more C style. C is like the only thing that's worth learning, honestly. It's so good. Simple M's. Oh, hey, there's Tim himself. I'm still waiting on that Sokoban end. That one is going to be super awesome. Simple M's versus more complex curriculum learning. Trade-off between M simplicity and achieving the best possible policy. Not necessarily, Tim. You can have very, very complex M's that have a smooth enough learning curriculum, like naturally, for you to just be able to do very, very well at them without having to do anything fancy with curriculum. It just depends on the problem. That's a different Tim. Damn it. My bad. Too many Tims. All right, what are we at here? 1037 lines. At least we don't have disgusting close implementation anymore. Let's take another quick look at this. Okay, we got weird shapes shenanigans to handle. A lot of weird shape shenanigans to handle. I'm just looking for bloat is what I'm doing. Okay, this is a dumb way of handling it, but it's fine. Yeah, a lot of the shape stuff is pretty bloated, I think. Shape stuff, and then what else? Rollout's impl. Ah, yeah, we do use this. Okay, let me read this create function for now, and then we'll figure out the shapes. What about Rust? Fuck that language. Look, there's one redeeming thing about C++, which is you can just ignore it and write C in it. Rust is just bad. It's like smart nerds focusing on completely the wrong thing for God knows what reason. At least I can work on deleting all the C++y garbage from this. Okay, we got default stream. What the hell is this? Act N? I see. Okay. Action space stuff. We just have like a lot of little things, don't we? This MK1D thing. It's all the same problem though, right? It's just like being jank making a tensor. Probably some stuff we can look at here, but pretty small. Is quite a bit. I think the main thing is going to be in how we're making these tensors. Like, what is this, right? Let's go look at TinyGrad's tensor. Why not? This is source of this page. TinyGrad GitHub tensor. Let's see what their code looks like. Class tensor. Ugh. I actually don't hate this. This is like somebody who's very smart with a very different style from my own. Where I don't think that that style is inherently completely stupid. This is like exhausting to read though. Device, D-type. So wait, it just gets data, device, and D-type. So you have a shape. Self.shape, right? Shape, D-type. UOP. So they track. Wait, what about the shape? Lazy evaluation framework, I see. Ick. Scalar type. Yeah, dot shape of, yeah, this is gross. Is the problem. What's this? Oh, they don't have, it's not open source. Good job, man. I don't like var args. Yeah, we're gonna need more than 4 dims. Derive. Yeah, this is good. Mm-hmm. Ugh, that's super gross. Just takes an array. How's that? I don't know what it's doing with this plan mode crap. D-type size is not good. This should be an enum. Why is it void star data? I want char star bytes. Dude, they have so much crap in here. Where's their tensor? Oh, it's Hugging Face. Cool. Matrix B. The heck did it just do? It just did something crazy stupid. Yeah. Char Star bites. And then you want this static, right? Hmm. Shape is really annoying. D-type size. Partial designated. Ooh, that's good. Try that. Hello, Chief Puffing Officer. It's going well. We are doing the highest performance RL now without torch. So that's pretty cool. No torch needed. Yeah, I think this is good. Cool. So, the thing is, I really want this to be C style, so I don't want to give this any functions. But we'll start with this for now. Can people still find jobs by doing regular RL? My guy, you realize that I could literally work in any area of ML that I wanted to within 2 months worth of background research, right? The core skills are the same. It's like math, engine, science. If you're good at any one, if you're good at any one of these, you're gonna do fine. If you're good at two, you can like do stuff like this. If you're good at three, well, there really aren't that many people that are good at all three. So I think that the goal here is just gonna be a char star Yes, good. No casts. Very nice. So I think that this will get us into clean shape casts, maybe. That'll save us a lot. And then from there we can probably go into kernels. Because kernels is going to be most of the bloat. Okay. Incremental. While this is doing this, in the meantime, so like realistically, we've got a little bit of jank in here, but it's only 500 some odd lines for vectorization. We've got the binding file, which is a binding file. And then most of the stuff is the models and kernels, right? So this is 15, yeah, that's like 3K plus. It's almost 3/4 of the code. Maybe like 70% of the code. Is just in models and kernels. So that's going to be the main thing to clean up. I just need it to be like not crap today so we can actually start on it. $6K. -1 is 5K. What you working on? Well, we have all of our training code in nice raw CUDA now. So I'm currently cleaning up our new CUDA RL trainer. Use Claude Code. Now, I keep saying I want to get rid of it, and I really do. It's kind of weird, honestly, man, because so the nicer the code base is, the less I use it. But the problem is that the last whole bunch of work has basically just been figuring out how to deal with the massive mess that Torch has. And it's just been like applying hundreds and hundreds and hundreds of refactor ops until we get Torch into something that is not gross, that still trains. And LM is very good at that, because it's very, very strongly verifiable in very small chunks of work that are really obnoxious to do manually. But like, ask it to design anything, ask it to make any sort of reasonable decision at all, it'll do it wrong every time. So I'm kind of accepting that it has a use, while I will still claim that people overuse the crap out of it and do really, really dumb stuff with it. See, all of this is just a refactor update. Keyboard. Widow Tournament Edition V4, 75% with orange switches. I like this keyboard. So I think it's going to be a little bit more of figuring out the shape. What we have? We got puff tensor. Okay, I don't like that we have these methods hanging off of it. But byte, shape, endim, size. It didn't bother to do a enum, did it? That's okay for now. I want to at least get the creations of this to be reasonable. Wait, byte, endim 0. Huh? Does this thing have a stupid constructor on it? No. I suppose we can also, I mean, this is like really simple shit. So in order to be more interesting on this stream, I think we can just go look at the kernels. As long as this hasn't broken it, we'll just go look at the kernels. Because this is really easy shit. I can do this off stream in the evenings. This is what I mean by they're just like a million of these really dumb refactor ops. It's like, yeah, let's try to do it like this. Let's try to do it like this. Let's try to do it like this. How much code did that save? Okay, what's it look like now? Right? So I was hoping that today I could stream some actually more interesting stuff, looking at the kernels and seeing what we have in there and what can be improved. In fact, let's just like start looking at this now. Well, this does this. Okay, so the top layer that we have here, we've got models C++. This has everything on the C++ side, right? So all these 4 decks here, these are 4 kernels. You see that these have CUDA types in them. So those are all just for kernels. So really this starts right here, where we have our allocator in here. This allocator should not be in models. We'll figure out where to put these. Allocator is really, really simple. It could be even simpler, honestly. Yeah, this should be like half this amount of code. So all the allocator has to do is give us contiguous memory buffers for parameters, gradients, and whatever else we want. You went to MIT? Yes, I finished my PhD 2 years ago, a little less. And now I do open source reinforcement learning, and I try to make the field that I spent the last decade of my life on actually be fast and sane. And we've had quite some success with that. All of our RL stuff is close to 10,000 times faster now compared to when I graduated. Like actually 10,000x faster, not making shit up. That's pretty cool. Cryo buffers. Yeah, cool. All the buffers are in here or whatever. More freaking high level. Okay, so there's just like a ton of duped like headers and jank in here, right? And then by 380, this is where we get to actual code. I mean, but it doesn't really do anything, right? We have native encoder. It's all super boilerplatey, man. It's all super boilerplatey. Which I don't like. Okay, well, like, look, this is just it being stupid, right? This is like, this is the fact that this is now not done in terms of layers, right? It's the entire multi-layer min-group in one struct, so duh, that's gonna suck. So of course this is a mess. Forward, train forward, backward. Okay. Then we got the policy. That's backward. Here's muon. Muon, I think, is actually pretty concise. Except for the tensor creations, right? Yeah, except for the tensor creations. Okay, well, at least now we know where the bloat is in here. This is very, very bloated, and it's mostly the boilerplate, mostly the creation of tensors. What do we got? We got PufferLib, C++, and we have models.cu. So this is anything that has a launch function. Namings of stuff kind of suck in here. So we got like 5 of these mapmul functions that are just cuBLAS wrappers. Add. Okay, yeah, these are just gem wrappers. I see. And then we have some, this is like just direct ported, I suppose, from Torch, the orthogonal in it. Let's see if this actually works. 859. 859. Perfect. 978. Cool. Bunch of casts and norms and clips, just random little functions. A lot of random little functions. Puff transpose. Yeah, the sad thing about this is death by 1,000 cuts is what it is. Is there a way to write kernels that work on all types of GPUs? Each company has its own supply chain. So it's more than just that, man. You're like, if you write CUDA kernels, they'll work on whatever NVIDIA GPU, but optimization can be very different for Blackwell chips. And it's also very dependent on what types of kernels you're writing. So like, the kernels that LLMs use for giant models are very different than the kernels that we use for very small models. So like, yes, technically there are a bunch of things out there that make kernels that work anywhere. It's just that at the moment they're all very slow. And they mostly do it by putting a bunch of abstracted crap in between you and the hardware, which of course makes it very hard to think about how your thing is going to be performant on different targets. We're not too concerned about that at the moment. We're concerned about fast and simple. And fast and simple equals just write your CUDA. So that's what we're doing. Yeah, so right here, this is like a couple hundred lines of death by 1,000 cuts. We also have all these like wrapper. I don't think we need these everywhere, do we? Hang on 1 second. Okay. So we don't even need all of this stuff. Does Puffer not rely on PyTorch at all? As of today, for training, no. We still have it in sweeps. We still have an optional Torch backend. It'll still be compatible. But I'm pretty sure we're going to end up with about the same amount of code before without the Torch dependency, and faster with some additional nice features just by dropping Torch. And it's pretty good. Okay, so the trick here is that, yeah, I think we should not have a separate models C++ and models CU, right? Because look, otherwise you end up hiding stuff. What happened here? I did /compact, and it didn't compact. The non-LLMRL stuff. Yeah, it's pretty cool. I mean, look, right? They do non-LMRL stuff, yeah. Yeah, I mean, watch this. Like, this is my local machine, right? Which is not even a super high-end machine. Right? I think the thing is that models should just be written in CUDA, because otherwise, look at the API surface, right? You see all this stuff? Like a bunch of these functions get called literally once, and you have a wrapper. You have a wrapper for calling this. Like this function should not exist. It's huge adoption. I mean, it really is, Tim. I keep seeing people doing stuff with it, even though I haven't really been promoting it all that much lately. I've kind of just been grinding on the new release. Yeah, this will end up saving a bunch of code. Like, there are a whole bunch of these kernels that literally get called once, that have a wrapper for no reason other than, like, the C++ to CUDA boundary. I think you should just be writing your code in CUDA C, and that's it. Like, you should not need launch function wrappers, right? Unless there's actually a lot of logic that's needed to determine a launch, you should just be able to call launches in line in your code. That's way better. It's way, way better. This should end up deleting like 100 lines worth of wrappers, I would imagine, and then additional, like, maybe 100 lines worth of headers. I guess then the question is, do we want launch functions in our kernels file as well? Or do we want the kernels file to be purely device side? Because, like, there are operations that you need that are reusable that require you to launch multiple kernels, right? There's still so much crap in here. I mean, but realistically, right? If I look in here, this stuff is fine. Right, these are just kernels. There's some constants and things that need to be moved around, but like this is chill, this is chill. Most of our kernel code is pretty decent. I mean, there's some stuff that can be simplified and compacted, but we don't really have any... There's not like abstracted jank in here anymore. I worked very hard to make sure there wouldn't be. So... well, all this at the bottom, I suppose. I'll try this. I guess I kind of signed myself up for an extra bunch of hours of work by doing this, but I mean, realistically, I think that this saves me time in the long run, and this should not delay our release. This basically just means I have to work a bunch of extra nights in the next week or two, but then I think this pretty much just gets us back on schedule, and cleaner, and with like nice new features and stuff. It'll be good. It's fun. Let's look at these in the meantime. Bunch of little kernels. Clip by norm F32 kernel. It's probably just a lot of them got to get merged, right? Honestly, I wouldn't be surprised if the reason that we have these is because, you know, porting the Torch ops directly, Torch does stuff this way. I think we're just going to end up with a larger number of small. Wait, is it? No, a smaller number of larger kernels. Because this like back and forth from host to GPU shit has to stop. It's really dumb. Like, what the hell is this? Come on. So I'm still optimistic we can get this thing down to about 4K lines. There's a lot of waste in here. Let me see what I would think that it should look like at the end of the day. Builds. Runs. Okay. Let's see what's in here. It probably left a bunch of logic in here. There's no way it's this long, right? Oh no, it left the Fords. Declared only. Okay, so this is a mess, but not that bad. I like to look at the line counts because I have an idea of how much code things should take. So I kind of do this to see what I think, where we think we should end up. Like, I think that this models.h should end up at like 3,400. This will end up at 900. I think this could end up at like 700, 600. And this is like 1,400. Yeah, so we can cut about 1,000 lines. I think we can cut about 1,000 lines. And this 6,000 number is really like 5,000 because PufferNet is something different. So is 4K lines good if we have like 500 devoted to VEC, 1K-ish for the main trainer, and 25, was it like 500 for models and 500 for models and 2K for kernels? That would be pretty good to me. I'd be happy with that. And then how many of these files do we even want? I think if we can get rid of 1 or 2 of these files as well. Little bit of merging. I guess I really just don't like the .h files here. Problem is we can't do anything about the .h files with vecend because this is needed for static compilation, right? Maybe we can. We'll see. But this should reduce some of it. And then I think merging of kernels is going to be a major one. I really want kernels.cu to just be like this clean thing that has actually useful functions that you can use for like most of what we'd want to be doing in our RL work. Actually, you know, sections of this code are already pretty good, and sections of it are still pretty bad, I'd say. Like most, I'd say at least half the kernel's code's really good. It's really pretty good. Half of it's still crap. Actually, let's see in the meantime, what... I don't understand why the models file is like this. Not this. Oh no, PufferLib sort of models.h. Why is the .h file like this? So like, okay, we have this buffer, right? And you essentially just register the shapes. And you give it a pointer, you give it a pointer and a shape? Hey, this isn't bad, right? But then why is it such a mess elsewhere? Okay, those are just high level. TPO loss. This doesn't get called at all. Okay, so it's got stale crap in here, right? Oh no, this is called in here. Huh. This is called in here. Interesting. The signatures on these just kind of suck. Okay, like at the very least, right, there is some stuff here where it's like it's done all the layers together. Yeah, like why isn't this in the encoder, right? Like right here, why is this not in the encoder? Oh, it is in the encoder. But then... Interesting. Oh, okay, I see. The design is actually not that bad in that case. It's not that bad. We will have to decide if we keep classes around at all. I'll build to verify. Okay, so that's minus 81 lines. And we just made the models file actually got a little bit shorter. And the CUDA here, this got shorter. So this was just a pure win. Nice. That's a pure win. Let me see if there's any more file level stuff I want to mess with before, because then I can make a commit at least. I guess the only other question is, like, is there a reason to create a CUDA C++ division in the first place? That looks nice. I really don't like the idea of having to introduce boundaries, right? Like, oh, this is a CUDA to C++ boundary. You need headers across this, right? I actually don't even like the static compilation boundary that we have for vecenv. I also like the idea of just having no C++ files in PufferLib. PufferLib.cu is pretty cool. That removes 1.h. And I suppose you still need this vecenv. But like, this .h is way longer than it should be, right? Because it has this stuff in the .h. So assuming that we can, oh yeah, and like, There's also some crap in here we no longer use. I swear, every time I end up splitting stuff up into a bunch of files, I end up merging it back. It's really, really next to impossible to maintain a good project design when you have a ton of files all over the place. Because it distorts, like, it distorts the amount of redundancy that you have in your project. Okay. It's about the same speed for compile. Still the same training perf as well. Same number of lines. Why do we have PufferLib.cpp? Okay, that's what I thought. No C++ files. No CUH files. Nice. Right? Now we have a total of 1, 2, 3, 4, 5, 6, 7, 8 files. PufferLib, we got models, kernels, bindings, vecenv. Why do we need models.h? We no longer need models.h. What up? CUH is CUDA header. Cool, so then what's going to happen is models.h will get merged back into models.cu. -1 file. This should actually be minus a good chunk of code. I don't know, header files are like... Anything that causes you to duplicate code is a very anti-human design. Because then you have to go manually update it in multiple places. So I really don't like, I don't like header files. Unless you're just writing your entire code in a header file, like header only, that's cool. Write this into there. This actually will give us a meaningful chunk of the goal. It should at least. And this gives us a very clean surface to think about as well. Each env the whole code is in a .h though, dude. The h is the source code for our envs. If you look at them, the .h files are not just declaring the types. When I say I don't like header files, it doesn't mean I don't like files that end with .h, right? It means I don't like files that consist of all of the decks for your functions. That I don't like. Actually, here's a great question. Why can't you just write a two-pass compiler for C and eliminate header files? Here's a dumb question. Oh, because the includes your literal. Modules. Me. That's like the type of stuff I would like actually want to learn more about. I'll go look at what Zig does, if it makes sense. Regular loose usage of .h, just declaring. Yes, it is. I don't know. It's honestly like, it's one of those things that I think very few programmers actually understand the internals behind this. And then like a lot of dummies just get Stockholmed into thinking that, oh yeah, you need to have the API defined in a file like this or whatever, which is just not true anywhere else. Uh, how about not deleting my comments? That's so stupid. Also, I didn't turn this auto accept edit thing on. It just turns itself on. And it keeps giving itself more perms without me doing anything as well. I think Anthropic just hates thinking. Would you be open to providing brief feedback on an environment I've been working on? PhD student? Yep. If so, how to contact you? Send you NFH. Yeah, that works. You can just send it to me on Discord. You can link it, or you can link me the GitHub on wherever. If you send me stockmarket.h, I'm gonna get suspicious. But if it's academic, then sure. Crypto.h. PhD students get free advice. Finance companies have to pay. Stupid thing, man. No, how did this end up with more code? Oh, it didn't remove this yet. Okay. Yeah, Claude will just like randomly delete all of the comments from code for no reason. But once this file is gone, then this gets thought it was going to be minus 200. Possibly it just didn't delete the headers though. We'll go see. No, it did. Okay, so it's only minus about 100 lines then. Minus 100 is still minus 100. Yeah, minus 100 is still minus 100. Yep, delete the models file, and now minus 100. Okay, what much more manageable, right? We've got 1000-line PufferLib CU. We've got a 1400 line models file, 1600 line kernels file. We got some bindings and backend, and then this you can ignore. And then this matches perf as well. Yeah, it adds useless comments and then deletes like the actual like, hey, this is how the numerics work here so that it doesn't explode. Yeah, see, so this includes interesting. I would like to have this be one file, the 1.h file. Include backend of h, binding h. Wait, how does this work? Oh. I think we can do this. Let's see if that works. I mean, I would just, it deletes a little bit of code. It removes a lot of silly things. It'd be very nice if we can just do this. You know? And then if we can do this, let's assume that this just removes, I don't know, 50 lines, right? 900 to go. That kind of has some dated stuff. I mean, but the big one in my mind is probably models and kernels is where the bulk of the fluff is right now. I'm gonna let this just go, and yeah, we'll do that. I'll be right back. I'm gonna make myself a mug of tea, and then we'll proceed. All right. Yeah. It's fine. And okay, it hasn't removed the vec-env. So 5912 is going to go down to, I swear, if it got longer. How did it get longer? How on earth did it get longer, man? I don't know how it broke that. There must be, I don't know why that didn't get caught before. Okay, so what's in here that it got longer? Probably just has stuff in a stupid order. Seek step. They're needed for PufferLib.ca, which only sees the top section. What? Okay, well that's weird, but fine for now. Well, okay, we end up with, I think now small amount to be done in vec-env, small amount to be done in PufferLib. I think those files are like they're like 80% done. So basically all the remaining complexity is the 3K lines here. which is good. Let's minus a bunch of code. Okay, so it's now all going to be in models and kernels. Yeah, look, norm, reduce, clip by norm. This is stupid, you see? This is completely stupid. Oh, wait, it's a reduce. I see. Maybe not completely stupid. Not completely stupid. No tuples? C and C++. Good. I hate Python. What on earth? It's funny. What? Did it just, like, not catch this? Hello, what is the goal? to have the fastest, simplest, and overall best reinforcement learning out there. Here, watch this train in like, I don't know, 6 seconds on my local desktop. There we go. This work? Didn't break it, right? Alright, there you go. I'm trying to see if this model's just dumb. If I just delete this line, what happens? Literally nothing happens. It's just dumb. Cool. What on earth is this, man? Why is this here? What if I put this up here? Does everything explode? Yeah, everything explodes. Cool. $13. Okay, so it's just like, it's really bad at organizing stuff, I can see. So, scale. All right, so we have a ton of really stupid wrapper functions down here. I think this is the main thing that we need to understand is the layout of this file, because really the only places where we have jank that I've kind of let the language model do really dumb stuff is some of the really small kernels down here. The ones higher up are handwritten, they're very good. It's all these little stupid kernels right here. Pretty much down from here, right? 1490. So we've got, yeah, this is all reasonable stuff up here. So it's literally just, it's 200 lines of kernel code in here. And then, I don't even know how much of this, a lot of this. Okay, so small puff tensor. This stuff relatively okay. Relatively okay at least. Native encoder, native decoder, mingru, policy. Wait, why is this? I see. I don't hate this. But that's why we didn't save anything on these declarations. Keep going for a bit. Okay, this is when it starts to get super jank. So we have a whole lot of matmul wrappers. Is orthogonal init this complicated? Is this actually the best way to do an orthogonal init? This seems super jank. Oh shit, this Malix. No, but it frees. Interesting. There are lots, it really is just like, it's death by 1,000 cuts, but I feel like I still have to find at least a few more big things. Like, what is this? AX pi. Remove CNNs? Good luck, man. Okay, so there is actually stuff we can do. think a lot of these are only used once. Mm-hmm. Thanks. I'm trying to figure out and visualize all code sections. Wait, well, this thing here is a mess. This is like brand new, and it needs major refactoring. When I'm done with it, it'll be very nice because it'll be about the length of the old code, but not dependent on Torch at all. Oh, I missed this. Puff transpose. Yeah, not dead code. And if CNNs are supposed to give you spatial locality, which is arguably useful in chess, kind of questionable. Okay, we'll do that for now. That ought to be a good bit of cleanup. I mean, it's just basically there are a ton of little kernels. Because, so why is the code like this, right? Well, it's because I ported this incrementally from Torch, and Torch is like this, right? So essentially, every single part of Torch is wrong. So the code that we are going to end up with is going to be of similar length, but it's going to look very different from the Torch code. Which is why we have all this refactor crap. That's funny. This is going to be stupid, isn't it? And I hope that this doesn't kill. Are these guys actually smart? Let's see. No. No, it's not. Okay. Well, that's okay. Do you have any suggestions? Just latest attempt to square features. Wait, per square features and embeddings. By 8 by. I think. I don't necessarily have any great ideas, Jess, on this. I mean, you can go look up the encoding that the other guys used. Is it big? We just want like some reasonable small encoding and then hopefully stack the recurrent cell deeper is going to be my guess. Okay, yay, these all get deleted. This. Taylor. You have to keep the assert, you fuck. I guess it's okay. It's like 0 guards. No. Still being used. Add stride to represent. Yes, you can. But chess is not large scale, man. Chess is very small. The problem is that, like, we want it to go really fast, and CNNs are not really fast. They're only just, like, kind of fast. Reduces dimension. How does that work with 8x8? It also reduces channel script. Stride Spencer confirmed that hurt learning. Yeah, I believe it. Do we build? Do build. Well, that doesn't work. Classic. Just break my code and bill me. Such a stupid workflow. This is so stupid. I mean, sadly, like, this is actually the best way to do this at the moment, as dumb as that is. Because this is sadly the best way to do this because it's just a bunch of really dumb refactor ops. And like until it gets into the state where it's pretty close to the final, it's just really gross and bloated to edit this by hand. Like I want to be doing the fine edits by hand, if that makes sense. How does it manage to break training? No idea, but it did. That would be minus 50 lines, though. To figure out what the hell it did. And it is from... It's actually... Yeah, that's actually better than minus 50 lines because it's minus 100 from models.cu and adding some to kernels. We want the kernels file to be big and basically everything else to be small. Like the idea is that essentially everything gets just chunked into a bunch of nicely fused kernels. It'd have to be the index or something, no? Actually, I don't even know how you could break it doing this. I'm gonna assume that this will be fixed, and then I'm gonna start looking for next stuff. Okay, so this is another big one here, right? Like we could potentially, I think the muon update loop itself could just get combined, right? My ignorant, wait, transformer based, no one's come up with alternative, transformer based. Well, it's just the thing for CNNs is its locality. CNNs are the fast thing that model that, Jess. Like, if you were doing images and asking how to replace comms, I'd just say, well, you shouldn't. That's the right thing to use. Um, the thing is that you're in the middle, right, where there's some spatial locality to chess, but it's not the same as with pixels. So you're kind of using the bias, but kind of not. So it's weird. It's a weird in between. Nope, this still not work. Did they just like? I'm gonna end up having to revert all this crap, right? We're not doing this. We're just reverting. Models are fucking dumb. My fault for trying to make it do too much at once, though. Okay. Go back. Such a waste of time. But then this got us down to 1,300 in models. Kind of have a weird in between here, don't we? Can we do theoretical research like finding an alternative to CNNs outside of academia or big league? Well, yes. It's not theoretical either. It's pretty practical. You realize academia is just like a bunch of grad students with no resources whatsoever, like sitting around and hacking on stuff, right? Yeah. So I don't know how we're gonna do our network architectures yet, how this should look. But this is not most of the code, is it? So now we're only halfway through the code. Not even, we're a third of the way through the code, and then there's a bunch of crap. So we got a bunch of matmuls here. And then we got our orthogonal init. And then, well, okay, some of these are getting removed, right? By this update. About 100 lines of this is getting removed, but we got a bunch of this crap. And then we have the really chunky kernels here. Really chunky kernels. I mean, we're kind of just dying to signatures, right? We're just dying to like signature call bloat. If it's 10 lines to call a function, like there you go. As best as I can see, it's mostly just wrappers and crap, right? So I guess then the other question we're gonna have is like, are we comfortable having our struct types in our CUDA functions? Because that would simplify if we just treat CUDA as I'm starting to understand. I'm starting to understand how we do this. Like, you all see the problem, right? Like, look at this. So, you have a function like this, train, select, and copy, that takes 10 tensors. All right, it does a little bit of calc, and then it calls a kernel with like the 10 tensors and the args in native types instead of in these types, right? Like this could just be deleted, and then you could just call this at the site, and then this could even potentially just take like, this could end up just taking one struct or something. It's just a matter of whether we want to have like custom structs in the calls to CUDA. Which, I mean, realistically, the answer is yes, right? Like the low-level functions that are just numerical ops or whatever, they should just use float or bfloat or whatever. Ooh. It's fine. I just want to do this for now. No, this doesn't match either. It's still deterministic. Hey, Liberty. We are doing reinforcement learning without torch. I have PufferLib working fully with no torch. And we are refactoring a whole bunch of crap. All right. So this is going to result in like minus 100 lines. And then essentially, there's some lines to be saved in emerging kernels that are very important. But then the biggest thing is going to just be from passing we're going to have to pass. It's the signatures are what's killing us, actually, you know? It's actually kind of funny there. Like, okay, there is some bloated logic, right? But I think it's mostly the signatures that are killing us. We are under 5K lines now, I believe. $8.46. As long as it's deterministic. It's fine if it changes the determinism a bit. How are we doing on lines? 869. 5,010 lines, because you ignore PufferNet. So this will take us under 5K. I would really like this code base to look like, 2K of kernels, 1K of puffer, 500 here, 500 here, or no, 500 here, and then bindings. Okay. I don't think there is. I just have to check. No pointers to host side objects. Ah, that's fine. What would this save us? I think that's a 20-line save per one of these that we do, isn't it? I mean, I think this saves us like possibly a couple hundred lines across this file if we did all of them. It's chunky. Pointers and dims, not full puff tensors. A lightweight arg struct is probably cleaner. CUDA kernel param limit is 4 KB. So it fits, but it's chunky. Okay, so that's something. Because did it get copied? Any CUDA devs in the chat? Does anybody know if this is completely stupid to pass full tensors to kernels? Compiler will optimize away any fields the kernel doesn't read. Interesting. I hope I'm not screwing this up. This will be so much cleaner though. Plus 15 minus 13. It's actually a little shorter even here. Oh no, wait, a little longer. So plus 2 lines. Plus 4, so plus 6 lines. So minus 20 lines. This will just get copied. That's going to be better. Host device. Should probably do something about that. Six. So this does work. What we do? Yeah, look. PPO loss forward, backward. Mm-hmm. This Kuda Malik is not. Yeah, this should not be there. It's a host. Yes. I mean, you see what I mean though, like about the amount of bloat. So even after I've optimized the crap out of this, like look at this function sig. Right? This is awful. No. No. It just does stupid shit. I mean, it's just like so much bloat, right? Submit this to one of those code review YouTube channels. Jess, like the vast majority of those are way worse programmers than I am. Like obviously this is crap, but you don't have context for like why this is crap, why this is a much harder thing to make not crap than normal, and what I'm doing to make it not crap, right? That was the joke. It's like the same type of like here. Like basically, if you look at something like this, where is it? One, two, three. All right, so if you look at something like this, and do you think this is bad code because of all the nested for loops? Like, you basically don't have the ability to think. You're just kind of applying the blindly, oh, nested for loops bad, and not actually looking at why they're here. Okay, good. This is way more manageable. Way more manageable. Actually, this is cleaning up the PufferLib, the main PufferLib file as well. So there's a whole bunch of just like struct creation garbage. I mean, just you see way worse code bases than this, unironically, just for no fucking reason. Like all the time is the thing. Like at least there's a reason why this is difficult to get into a good shape, right? Like this is trying to go from a very, very bad design that is dependent on a ton of abstraction and like just basically every possible thing being done the wrong way into the simple, clean way. And it just takes a lot of work to get there. Because you don't want to break training at any point, right? So you basically, instead of just implementing the thing the clean way, you have to do it by applying transformations to the gross thing. And that just takes a long time. But we'll see after this how much code we have left. Did not update my... Average number of SPS. Liberty, I don't even know. Super freaking fast. Like, you can hit close to 15 mil if I close the stream and all the other stuff I have running on my low-end machine. So, it's fast. It's like 12 with stuff closed. I think this is a slightly small... Yeah, this is a smaller net. But don't worry, it's fast. It's faster than Torch, by far. Like, this will gain us perf, because we're going to pure static mem and everything. Okay, this is actually a very, very nice improvement. We now have 5785, which subtract this, about 4900. And if we look at this, we now have 930 lines in PufferLib CU, which is better. Slightly more lines in models.cu, which I don't like to see, but at least I think that's like the first step in pushing them into the kernel file. And we have fewer overall lines, which is also good. Replacing torches. Well, hello, Finn. Talk on Saturday. We'll send Google Meet. Thank you. Yes, I did make slides. I have to go through them and actually figure out how I'm going to put everything together. I basically did a mashup of some neural MMO stuff that's more accessible for my thesis defense. Because I didn't get... Did you tell me what the audience was like? I went for like cool but accessible with some amount of technical depth. And so it's a mashup of some stuff from neural MMO and then my RLC talk with a couple things at the end about what I've been working on recently. And looks like you're doing cool stuff with the drone as well. Let's go through here and see what... Let's see what we have left. Bunch of Q blasts. I do wonder. Diagonalization. It's definitely getting better. Undergrad, cool. So I will talk about a bunch of cool stuff I've done and get people excited, add some amount of technical depth for those who want it. It'll be cool. I gotta go through it a couple of times at least. Not going to be polished to the extent that my thesis defense was, obviously. That was 3 weeks of work to prepare that delivery. But I will endeavor to give an entertaining talk. It is also get some people interested. Yeah, this thing is freaking massive, man. Look at this. Massive. Is good to see you around. I've just been fighting and fighting and fighting this nuts stuff. I mean, we have Torch out. We have super fast compile now. We're below 5K lines. Ignore PufferNet. That's not part of it. Below 5K lines. 1, 2, 3, 4, 5. Was it 5 files? The main thing that needs to happen is this chunker needs to get smaller, and then kernels needs to be bigger but clean. A talk be recorded. Ask Finn and Sam. And they invited me to give a talk. I will give a talk. Finn and Sam have done all sorts of cool stuff. Go check out their drone stuff. You can follow them both on X as well. They have done really awesome stuff with Puffer plus drone. Let's do... Well, first of all, same, yeah, so this. Ugh, the Muon code is so bad. I think that gets fused as well. Fuse everything. Can anybody tell me if this is stupid? Like, basically, I'm wondering why do we go back to host every time there's a reduction op when it's literally the same, it's the same launch args, right? So like all this would just become one thing. You're never gonna need to compute the loss without immediately doing dot backward anyways, right? I guess technically gradient accumulation, maybe? Does that matter? Really doesn't matter, right? Because you would just do... Yeah, because you just get the grads anyways. My best record talks. You're welcome to record yourself if you'd like, Joseph. Should I stream the talk? And just turn the chat off? I could do that. I don't know if there are restrictions. That's fine. Cool. Just literally will do my normal stream, and then we'll go join talk, give us talk, and it'll be cool. Nice and easy. Very well might break this, but if that works, that'll save us another, I don't know, 30-ish lines. And then what else we have? I think Muon. Got the multinomial sample. Advantage. I think actually I should do all of this stuff in place for now. We're gonna end up changing this anyways later, but I think we should just change all the functions to be in place. Because I can't actually tell how much code is for what now, with the way that I have this set up. Is there ever a time when update epochs is going to be more than one? Yes, Jess. And actually, update epochs is getting replaced with replay ratio in Puffer 4, which just means that, like, on average, this is the number of times you use each sample. And it can be float valued. It doesn't have to be an integer. And it's just included in Puffer sweeps now. It's pretty cool. And let's look for other stuff in the meantime. So, yeah, this thing sucks, the way that we have these tensors. I'm going to try to mess with this, actually. Naming conventions. Jess, you'll get a summary when I'm done changing stuff. If I tell you all the new names and I decide to keep changing them until release, you're going to be annoyed. So let me cook on stuff for now. Let's see if this trains. Nope, not at all. What the heck did it do? Where are the losses, man? Oh, they're in there. The losses are there. Presumably coup de grace is like pruning or doing something weird. This would be very good if it worked though, because if we could get this to, I think a version of this works and is going to be, yeah, minus 80 lines. Is that more than minus 80? That is more than minus 80. If that is minus 140 lines. That would be very good. That would be very, very good. And it would be coming out of, well, mostly out of kernels, funny enough. Alright, because you don't dupe the massive SIGs, right? Yeah. That would be great. That'd actually be great. Of course, models is still massive. I'll be right back. I use the restroom. I'm going to get myself another mug of tea, and we shall continue for a bit. All right. Okay, this works. What do you want to bet that it just reverted it? Okay, cool. Actually did it correctly. Yeah, that means we should be catching our errors, most likely. Solid, right? Very good. Make sure. But that looks very, very nice to me. And did we keep our... Yeah, 12 line price. So we now are 4,800 lines. 4,800. That's good. This is just going to be so we can actually see how much code each thing is taking up. I actually don't really want these tied to a struct, but for now I need to see how much code they're taking up. We'll save us a few lines of forward decks as well. Oh, well that's really bad. That's like really bad for us. Okay, so encoder needs to also be. Yeah, so it misinterpreted, that's fine. That's at least some of it. Yeah, native encoder. Because we basically can't see how much code the min crew is taking up. Let's start with this. Three. And this should save just a little bit of code, but then the main thing is we're going to see the groupings. And then we'll be able to essentially do a good assessment of what we can actually save in models. Which should only need to be another, actually quite a bit. I would like that file to be short. There really should not be that much in there. Still, good progress. Kernels does not depend on them. So that should be fine. I am a little lost with how to start with RL. Should I use gem or start with PufferLib? Coding RL. I want to get into coding RL agents. Well, gem will be super freaking slow, so I don't recommend that. Gem also doesn't give you a training implementation. It actually gives you basically nothing other than an API and a ridiculously slow multiprocessing backend. So if you want a good way to get started, check this out. This is going to be all of my best advice and pretty concrete, like do this, then this, then this, all in one place. It'll get you starting writing some stuff very quickly, and it'll fill in theoretical gaps along the way. Your voice is repeating. What? Anybody else? Shouldn't be. Mic settings look fine. Is my audio screwed up for anybody else? Never mind. It's good. That article has everything. You just post on Reddit for this? Cool. It definitely doesn't get to be 335 lines, so put the code back. And then I can actually look at it and see, I mean, I suppose I can start in the meantime, but it's kind of tough, but without it being set up nicely. I suppose it's going to be like coarse, medium, fine. So coarse is just like having this thing do big chunks of stuff. Medium is going to be like me tagging little things here and there, and then fine is going to be me editing the rest of it by hand. There's some stuff that it's like, I just can't believe that it takes this much code to do an orthogonal, when it's literally just calling a solver, right? I guess because it's the D-types. It's kind of screwy though still. Move on step is painful to look at, but like we're not going to really save code here. We might save some perf. I mean, the only other thing I can see here is possibly the tensor creation patterns. If we one-line the tensor creation. And it waits. No. We also don't know if orthogonal initialization actually does anything, to be fair. I don't want to mess with that though until we ablate. Okay, so we clean up. We went from that is sketchy. I don't see how we would have saved 200 lines. It must have deleted something, right? Apparently not. Apparently there was just a bunch of redundant crap. So that's cool, because that means we are now at 5,600. 5,600 lines. That is very good. Oh, and I also gotta check on Spencer. Oh, we're good for now. Okay. Allocators, all this. I want to try one of these. these puff tensor allocations. Like if I do this equals can I just do this? Screw you, C++. Let's just see. What happens if I just do this? I wonder if it just works. Yeah, it just works. Okay. That's way better, isn't it? I like that much more. It's not really going to save us any code, unfortunately. Let's see. pass a point. Of Yeah, you just have to pass size, right? Size of array. Wait, how does this thing work? In the same scope as declaration, it does work. Inside function. So that's a little sketch, right? I think this is how you have to do it. Especially if we're going to do the inside function parameter doesn't work. That's a compiler, okay, that's fine. I wonder if ndim is they're automatically zero initialized. That's nice. So we don't need ndim. That will actually save us a few lines throughout the program. It also just makes stuff way nicer. Way, way nicer. And all it needs is the shape. C99. Very clean. And then literally, because of that, the you can do view just by editing the shape, which is really nice. We can actually make a puff view function so easily with that. And then all that a tensor will need to know is its bytes, its shape, and the d-type size. Probably should just be the d-type. I mean, we'll see. But that's a very easy refactor. Should save, I don't know, a few lines. And then the next thing, let's go look at our allocator, because this thing looked big. Man, like, why is it this complicated? Puffer registration. And I did it this way. I did it this way so I could zero some stuff, didn't I? Mm-hmm. It's probably just better to have 3 allocators, right? Yeah, this is a little janky the way it is. At least these shitty one-liners here in models are now actually reasonable. That's defensible at the least. Mm-hmm. Bytes, shape. Yeah, this is what we wanted. See all these? Look how much better this is. Dot bytes, dot shape. Instead of this, you get these just nice struct initializers. That's the main thing I wanted. And look, it actually even gets rid of this because it realizes that this function sucks now because you can just do it this way. Isn't that cool? So it actually just deletes this because it realizes that this thing is shit now. It didn't realize to do this from the start, but once I do it, it realizes, oh, okay, we don't need this. And that actually was specifically one of the functions I was looking at is why the hell is this here? So I guess then the question is going to be how much code this saves and whether anything is broken. It's trying to build it though, so it should work. Let's see if it works first, and then we will get the line count. Want to be at least be a little bit less, right? Okay. That looks like it works. Yep, that's the exact same result as before. Ooh. That's actually better than I expected. What is that? That is... It's like 60 lines, isn't it? 50 lines? Yeah. That is very, very nice. Where did they come out of? We got 36 lines out of PufferLib.cu. And we got 28 lines out of the models file. That's nice. That's very nice. Huh. It is 60 lines. That's nice. 64 lines. Cool. I'm gonna make a quick commit. I'm happy with this. Well, we're gonna have to do all the binding files at some point, right? Takes a lot of refactor. But wait, actually, what is that now? So this 5378 minus. I cannot add 4,500. We might actually exceed the target. I think I could get this even lower. Okay, let's go check the allocator. I think it would decrease. Yeah, this will be better. You'll only end up needing one of these. I think you will end up saving like 20 lines. How's our tensor class looking? That's already pretty compact. I don't like some of this stuff, but it's already pretty compact. So let's say that that's going to be fixed on the allocator. This is clean. Some of this stuff's a little weird. I'd say, like, yeah, some of this is definitely a little weird. At least it's defined in a weird spot. Oh yeah, these are going to get all removed because these don't need these comments here. These just need to be renamed. So this is going to be another 20 lines. I can do that. The orthogonal stuff bothers me. Um, ah, I see. Tanh and sigmoid. I think I just inherited this from CleanRL. This, yeah, we do have RNNs. I don't actually know if you need this. We could try it, because it's just annoying that we have to have it. All right, let's see what this thing has gone and done. I'd want to ablate it at least on one harder end, not just breakout. Allocator set. I see. That's going to end up being the same amount of code, isn't it? Well, these can get deleted, honestly. Did save 28 lines. Let's make sure this still trains. Doesn't train. Good job. What? Sometimes trains? Where is Spencer? Might be finishing stream in a second. I got some client work to do with Spencer. Yeah, we're gonna finish the last couple left here though. How does one start with RL in Big 2026? Theoretic first approach not me the best. I have a guide for you. This is my most asked question, so I wrote a really, really good guide for you. So everybody kept asking. This is my single best piece of educational content. Here you go. Boom. If you do this, you will learn RL. If you already are a decent engineer and have at least some relevant background, you will be doing RL quite reasonably within a few days and very reasonably within a few weeks. And you'll basically be able to contribute to like latest research within a few months. If you allocate like a few solid hours to this a day. If you're not familiar with my programming in ML guide, there's a more general one that comes before that that's very, very helpful if you're like not used to reading scientific papers and stuff. I'm setting a very bad example, frankly, with what I'm doing now with the stupid language models. The amount of code I'm letting them write. But I'm kind of stuck this way until I at least get this code base into a reasonable shape. Okay, this is the number that we want. That'll save a few more lines. I guess maybe it's not clear to people, but when I say, oh, it'll save a few lines, like, line count is not a perfect measure of code complexity, but assuming you're not gulfing crap and introducing more indirection, if you're like deleting indirection, generally making lines the same length or shorter, and you're removing count, then typically you are simplifying your code base. So, there's a certain reduction of complexity in my mind that is associated with going from 5,000 lines to 4,000 lines, right? And then in my head, I have like, if I get this to 4,000 lines, that'll be reasonably lean, not too much fat. If I get it to 3,000 lines, it would be super, super lean and concise, right? And the fat is always the confusing bit as well. Like when you have code that's doing the minimal amount of stuff that it needs to do, there's basically nothing left to confuse anybody because like you're only doing the operations that are obviously required, and it's very, very natural. It's just like very, very natural. Okay, so there you go. So now we are at 5340 lines minus, was it 5340? All right, 4481. Because puffer net.h doesn't count. This is for something else. So this is now like less than 1,000 line penalty for not using torch. And depending on if we need orthogonal and depending on a few other things, I think we can definitely get this to 4K. We can maybe even get it down to 3.5. I will be very, very happy with that. Let's just let's clean this up real quick. Let's make a nice commit. I'm probably going to be back in the evening. I don't know if I'm going to stream it. Like, we'll see about that. I might keep streaming. And look, minus some lines. And we have at least another 50 for free. It's all bringing us closer. I gotta go do a little bit of client work now, guys, until dinner, I think. And then, depending on when I get back from dinner, I will either stream or I will keep working on this, but I will be working on this either way. Tomorrow, I have some client work to do. So it depends on how long that takes, whether I'll be streaming this tomorrow or not. I will be streaming this on Saturday as well. I also have a talk to prepare tomorrow, so I probably will not be streaming. We'll see. I have a talk that I'll be giving on Saturday, so it'll be like stream a bit, give a cool talk. The talk will be streamed as well. So if you're interested in just hearing more general, more accessible stuff on my work on neural MMO and on making complex environments and on how we make stuff fast, all of that in a more accessible format. I will be giving a talk. It'll be just broadcast here on my stream, but it's also for university. And then the rest of the day, Saturday, will be devoted to continuing to clean this up. We almost have this to the point where we can just like start running experiments on it. I want to make sure everything's super stable before we do that. It was pretty good so far. So thank you all for tuning in. If you want to support my work for absolutely free, takes 5 seconds, just start the GitHub, like start Puffer on GitHub. It really helps me out a lot. You'd be surprised. You know, we do have a business tied to this, and it helps companies see my work, even though it's all open source. You can follow me on X for more content, and you can join the Discord to get involved with dev and get